This question is a proof demonstrating how eigenvalues transform when a square matrix A undergoes specific operations. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. Let capital A be a square matrix of size n by n, and suppose it has an eigenvalue called lambda. Prove the following two statements. Lambda plus k is an eigenvalue of the matrix A plus k times the identity matrix. Lambda raised to the mth power is an eigenvalue of the matrix A raised to the mth power, where m is any positive integer. First step is to understanding the definition of an eigenvalue. We are told that lambda is an eigenvalue of the matrix A. This means that there exists a non-zero vector, let's call it alpha, such that when we multiply matrix A by the vector alpha, the result is exactly lambda times the same vector alpha. This key property will be our starting point in both parts of the proof. Next step is to showing that lambda plus k is an eigenvalue of a plus k times the identity matrix. To begin, we start with the known equation. Matrix A times vector alpha equals lambda times alpha. Now consider the matrix A plus k times the identity matrix. Multiply this new matrix by the same vector alpha. This gives a times alpha plus k times the identity matrix acting on alpha. Because the identity matrix does nothing to the vector except return it, the result becomes lambda times alpha plus k times alpha, which simplifies to the quantity lambda plus k times alpha. Since alpha is unchanged and still not the zero vector, this shows that lambda plus k is an eigenvalue of the matrix A plus k times the identity matrix. Don't forget that the identity matrix simply returns the original vector when it acts on it. Next step is to showing that lambda to the power m is an eigenvalue of A raised to the power m. Again, we start from the equation that matrix A times alpha equals lambda times alpha. Now apply matrix A to both sides repeatedly. First, a times A times alpha becomes A acting on lambda times alpha, which is lambda times A times alpha. This results in lambda squared times alpha. If we repeat this process m times, we find that matrix A raised to the mth power acting on alpha gives lambda raised to the mth power times alpha. This means that alpha is still the eigenvector, and the corresponding eigenvalue has become lambda to the power m. Be careful not to apply the power operation directly to the product A times alpha. Remember that the power applies to the matrix first, not to the result. When a matrix is modified by adding a multiple of the identity or raised to a power, always test its action on a known eigenvector. It quickly reveals how the eigenvalue transforms. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.